Hey everybody, I'm at a meeting today, so I got this nice video for you guys to watch. I want to introduce these interaction diagrams, which is a new representation of interacting objects that we're going to use in this class as situations get more complicated. It's sometimes very difficult to go straight to a force diagram, so an interaction diagram is kind of an in-between from a picture and a force diagram, and it can be a very useful tool. So the tactic box on page 169 in your book describes these interaction diagrams, and I want to simplify these rules just a little bit and modify a couple so that these diagrams become more useful. So in the notes section, you can copy this stuff down onto your worksheet. First rule will be to represent all the objects as circles with an abbreviation inside of them in the layout that's kind of in the picture. Okay, the second thing is we're going to use this to identify interactions between objects, and the rule is that every interaction connects to and only to objects. The third rule is that whenever there is a surface interacting, there can be at most two interactions at a surface. One is a frictional force that's parallel to the surface, and two is a normal force perpendicular to the surface. You don't always have both. Sometimes you have one and not the other, but you need to look at the situation to decide. You can never have more than two interactions from the same interface. Okay, and lastly, the book describes having kind of the entire Earth as a separate object from the ground or the floor if that were to show up in a situation. And that is something that I do want to include. But in the book, they talk about having the entire Earth interact only through the gravitational force. And we are not going to put that restriction on. The Earth can interact through any of the forces that happen to be acting on the entire Earth. And we'll use kind of number one as an example of how, if we don't allow the Earth to interact in other ways, we kind of back ourselves into some difficult conceptual corners. As you can see, this fourth rule will say only the entire Earth will interact through the gravitational force, and that we will continue to do. And basically what we're saying there is that only the Earth has enough mass for the gravitational force to be something worth considering. There's gravitational forces between any objects that have mass, but objects that are significantly less massive than the Earth have such tiny gravitational forces that we'll ignore them. So gravitational forces will only be between objects and the entire Earth, and other forces may arise between the entire Earth and objects like normal forces and frictional forces if necessary. Okay, so those are the rules that we're going to use to draw these things. Now I want to put some examples on the page here so you can see what these things look like. I will also draw the force diagrams that match these things, and I'll use those force diagrams to show why, only allowing gravitational forces from the entire Earth leads to some problems. Okay, so here you can see a block resting on a table, and this is number one on your worksheet. So the first thing I'm going to do is represent these objects as symbols and circles, and those will be what the abbreviations that we'll use throughout this problem. So we have a block, B, it is over a table, T, and then the entire Earth will be down here below all of that stuff. Okay, and so my list of interactions, the book adds some additionals into the kind of catalog of forces that they talk about. The ones that you should be familiar with already are normal force, frictional force, tension force, and gravitational force. Those are the same ones that we used last year in Physics 300 and Physics 400. The book introduces a spring force, which is very much like a tension force. It introduces a thrust force, which can be considered a kind of normal force. And then they introduce one more. What is it? Yeah, their other one is electric and magnetic forces, so electromagnetic forces, which is different, and so we can include those now. I'm going to continue to use these for normal, friction, tension, and gravity because it's just less for me to remember. Okay, so here's how these work. I got my circles. Now I'm going to draw connecting lines wherever they interact. So the block and table definitely interact. And what I'm going to do is use a solid line to represent a contact force. I'm going to label this kind of interaction. This would be a normal force interaction between the block and the table. Then there is a gravitational interaction between the block and the earth. And for that one, it's a long-range force, and I'm going to be using dotted lines to represent long-range or non-contact forces. Likewise, there is a gravitational interaction between the table and the earth. So another dotted line here, and label that interaction as an FG. And then finally, there's going to be a normal force interaction between the table and the earth. And again, this is something that the book would not allow, and I want to show you how if we don't include that, it becomes very problematic. Okay, so that's it. That's what the interaction diagram looks like. And we can then use it to draw our force diagrams because we've basically made the decisions about which forces belong on a particular object's force diagram. We've set up a bunch of symbols and abbreviations that we can take advantage of. And we have only left, the only decision we have left is to decide which way these forces point. Okay, in this example I recognize is pretty trivial, but you'll see later in this worksheet how these interaction diagrams alone are complicated. Then figuring out what goes on the force diagram adds additional complications, and being able to break this sequence of tough decisions up into a couple of steps, I hope you will see, is very valuable. So here I'm going to use that symbol here to draw the force diagram for the block. So there's two interactions. I already have decided that. So the two interactions that I need to get on this diagram are this normal force and this gravitational force. So I think about the normal force on the block by the table. That is an upwards force. And now I can use on by notation, but I can abbreviate Fn on block, comma, by table. So I'm just going to do normal force on block by table using my previous abbreviations, where the on always comes first and the by always comes second. Then I have this gravitational force. It's got to point down because the forces on this thing have to balance. I know these two have to be equal sized, and so now I have gravitational force on block by table. All right, I'm also now set up to draw the force diagram for the table, which is not something that we've typically done, but that's what I see as the beauty of these interaction diagrams is those decisions are already made. I can now draw a force diagram for the table. There is a normal force on the table by the entire Earth. All right, and that is going to be upwards. Fn on table by the entire Earth. And then there's a gravitational force on the table by the entire Earth, and again it's going to be equal and opposite. Gravitational force on table by the entire Earth. So those two forces are equal. All right, if I didn't allow the entire Earth to interact through that normal force, then this diagram for the table, the force diagram for the table, wouldn't make any sense, because it would look like this, and that's an unbalanced force. That would mean that this table is accelerating downward, and we know that that's not true. So this is the primary reason why I need to allow this entire Earth to interact through other means. Okay, and then we can also draw the interaction diagram for the entire Earth using this diagram, because we've made these decisions already. So the entire Earth would look like this. There would be a normal force on the entire Earth by the table. On the entire Earth by the table. And then there would be a gravitational force on the entire Earth by the table, and a gravitational force on the entire Earth by the box. All right, and you can see that we've already decided that the Earth has to interact by 3 different interactions, those 3 that we had laid out. The last thing I want to show you guys is that these diagrams are really useful for identifying Newton's third law interaction pairs. So this force here, normal force on the table by the entire Earth, is the same interaction as this one here. So these 2 forces are exactly equal and opposite, and that's the Newton's third law. For every action, there's an equal and opposite reaction. Likewise, this force here, gravitational force on the entire Earth by the table, is the same interaction as this one here, gravitational force on the table by the entire Earth. So those would have to be equal. And then lastly, this, I see a mistake here. This is not a gravitational force on the block by the table. This should be a gravitational force on the block by the entire Earth, because only the entire Earth is interacting through a sizable gravitational force. So this force here, gravitational force on the entire Earth by the block, is the same as this force over here, gravitational force on the block by the entire Earth. Okay, so that's a basic interaction diagram. I'll post a second video that does the same thing for the second example problem on your worksheet, which if you need additional support, you can watch that one. If not, you can go ahead and get started working on worksheet 1. We're going to start whiteboarding this stuff tomorrow. I would expect you to get through maybe the first 6, I think, would be appropriate. So problems number 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7. Yes, 2 through 7 for tomorrow. And I'll be back then. See you then. Bye-bye.